This is a seed. Specifically, this is a bean seed. I tried to cut it open because I thought it might be interesting, but it wasn't. So instead, I drew a diagram. Seeds are really cool because they have everything the plant needs to get started already stored inside of them. Those leaves that you see will become the primary leaves of the bean plant. It also contains nutrients that the plant will need to sprout. And now, I'm going to tell you the story of my bean. It started off having a very good life. The seed germinated, and it grew. It looked very healthy and happy. And then, the night before I left to go to Russia, I carried my bean through the cold to my friend Lucas's house because he was going to take care of it while I was gone. By the time I got there, my bean smelled like a green bean salad. When your bean plant smells like a green bean salad, this is very bad news, because plants emit these smelly chemicals when they are dying. It's their way of screaming for mercy. By the time I had returned from Russia, my plant had met a tragic end. Carrying it through the icy wind likely froze the water in the cells and destroyed the cell walls. I was heartbroken. Also, I was quite certain my TA was going to murder me. So I did the only thing I knew how to do and called my mom to cry. She sent me a bean in the mail, and I planted it the next day. I'm very pleased to say this plant is still alive today. Here he is in all of his glory, Larry the legume. As you can see, he looks quite healthy and happy. With that said, I'm going to decapitate him. The secondary growth of this plant yielded trifoliate leaves, meaning that there are 3 of them. Now that I have decapitated it, it is merely bifoliate. And now I will show you a diagram of the bean plant life cycle, because it is on the rubric. The very most important thing to know is that meiosis is on one side of the cycle and fertilization is on the other. Additionally, the life cycle is split into a haploid generation and a diploid generation. Remember that the gametophyte generation is haploid, while the sporophyte generation is diploid. An interesting thing that I noticed about my plant's anatomy is the root system you can see on the screen now. Roots take in nutrients and water. Tiny root hairs are responsible for this absorption. The xylem then carries water and nutrients from the roots to the plant's extremities. At the same time, the phloem takes sugars, the products of photosynthesis, from the leaves to wherever they are needed. On the plant you were looking at on the screen, you can see a shoot growing upwards. At the very tip of this shoot is what we call a meristem. The meristem is a zone of undifferentiated cell division. Another thing presently visible on your screen are what we call axillary buds. These are buds that have the potential to become new shoots. Another interesting thing that I learned about my plant is that it responds to external stimuli. This is called a tropism. At night, when the sun goes down, the leaves fold downward, and in the morning, when sun hits them, they fold up again towards the sun, as if to say, "Good morning." If you looked at this leaf under a microscope, you would see tiny holes called stomata. Stomata, with the help of what are called guard cells, regulate the flow of carbon needed for photosynthesis into the leaf. Here is a diagram of my baby plant. Those are the roots, which make up the root system. The big root in the middle is the primary root. The leaves at the top of the plant are the primary leaves. Those are the leaves that you saw inside of the seed. Those other leaf-looking things are called cotyledon. They're not real leaves, they just provided nutrients for the plant when it was just getting started. Now they will shrivel up and die. One thing that I omitted from this diagram, but must mention, is the terminal bud. This is the bud that is located at the very top of the plant on the main stem. Thank you for watching. I hope you've been enjoying this video.